Welcome to Monkey Physics IIT JEE NEET Foundations.
Let's focus on motion under gravity. Our next topic is motion under gravity. So this is the best example for constant accelerated motion. Constant accelerated motion. Of course, this constant accelerated motion we can discuss in 1 dimension and 2 dimension also. For the time being, we are focusing only on 1 dimension. So for 2-dimensional case, first we should have the idea about the vectors. After focusing on vectors, after finishing of vectors, we can discuss about motion under gravity in 2D. Now, motion under gravity in 1 dimension. This is in 1 dimension, that is our in straight line we are discussing. And that constant acceleration in this case is nothing but acceleration due to gravity. Acceleration due to gravity. Okay, yeah. Then, how many cases are there? First of all, in how many situations we can call? We are going to study about the motion under gravity. The first situation is, this is case 1. Object is dropped from some height. It's a drop. Whenever we say drop, its initial velocity is equivalent to 0. Now object is falling down, reaching to the ground. Now it is dropped from the height h. So this is the situation. And what about the acceleration? Acceleration due to gravity is downward only. Now case 2, it's a object is thrown up from the ground. So when the object is thrown up from ground, so it is going to reaching to the maximum height. So when do we say it reaches to the maximum height? When it stops there, isn't it? It won't go further high. Then its velocity is 0. So this is what it reaches to the maximum height h we can. Yeah. In this case, even acceleration due to gravity is still down. Now, case 3 is if the object is thrown up from some height h. Okay. Now it's thrown up. Now in this case, in all the cases, acceleration due to gravity downward only. Now case 4, so the object is thrown down from some height h. Now these are the 4 cases we are going to discuss. Now in all these cases, acceleration due to gravity downward only. Okay. And based on previous classes in this same chapter itself, previous videos, we all have the idea about the equations of motion. What are those equations of motion? V is equivalent to u plus at, S is equivalent to ut plus half at square, and v square is equivalent to u square plus 2s, and Sn is equivalent to u plus a by 2 into 2n minus 1, and even displacement is average velocity into time. So these are equations. Okay. Now, I told you these are valid for constant accelerated motion, isn't it? And now, motion under gravity is the best example for constant accelerated motion, I said. Now, how these equations are going to be applied here? Is there any changes we need to do based on the situations or conditions? Now, when the object is dropped from some height, what is the velocity after some time? You want to use this formula. Now, in this case, if object is thrown up, what is the velocity after some time means this formula only applicable. But we should not use the same as it is in both the situations, because in this case, the initial condition, initial velocity, that is 0, is 0. So V is equivalent to acceleration due to gravity, gt. Yeah. So here, acceleration due to gravity. Now, the main point where most of the students confuse about the sign convention to be given to acceleration due to gravity. Now some situations are in these cases, few cases this to be given as positive and few cases this to be given as negative. Why it's so? And when should we give it as a negative sign? Now listen carefully. The velocity is given here, right? It has 2 terms. Anyway, this is fixed, constant. Now based on this, now the moment when the object starts its journey in any of the cases, consider. So the moment when it starts, now after time goes, if the velocity keep on increasing and it never decreases once it starts its journey. Example here, it starts its journey here it starts its journey, here it starts its journey, and here it started its journey, right? Now in this case, once the object starts moving, it never decreases its velocity. So velocity keep on increasing. And here once it's thrown up, and for some time while reaching up, it decreases its velocity and then increases. Now here, the decrease in the velocity, then how is it possible? In these two terms, one term must be negative. So when the negative term is involving, then only this value decreases. So that we need to understand. Why this negative term? Because if you are taking u as positive, upward direction as positive, acceleration due to gravity downward is there. So these are opposite to each other. So acceleration to be given as negative sign. Now in this case also, with this explanation you tell me here, shall we give g as negative or positive? Think of it. Now once it is thrown up, while going up it has to decrease. Velocity decreases. Decreases means the negative part must be there in the expression. Therefore acceleration due to gravity sign to be given as negative. And here once it starts journey, it's moving downward, even though it is thrown downward only, moving downward. While moving downward, it never decreases its velocity, right? So there is no negative sign to be given. Or else we can do one thing, initial velocity downward, give negative, acceleration downward, give negative. So negative, negative, both the terms are negative, so it's keep increasing. There is no decremental point. Hope it's clear to you. Now based on this logic, tell me, just you think about it, this, here, acceleration due to gravity. So what sign we have to assign? No need to give negative sign, or no need to follow the sign convention. Here we have to give negative sign to the acceleration due to gravity. Here also negative sign to the acceleration due to gravity. Here no need to follow the sign convention. Hope it's clear too, right?